Good morning, guys. Today is going to be a
Audible.
class.
Ma'am, in the Google Drive, the PPTs uploaded are only of the first chapter. It's been uploaded twice.
One sec. Let me just ask you. One sec. Yeah. What is it? I have. Okay. You may see one chapter uploaded twice, but then it is not uploaded twice. If you recall, my first lecture we had not recorded. The first lecture was not recorded, so that portion. It is not the full chapter. That portion I have just with whatever I have written, I have just posted that PPT.
Yes, ma'am. So the second slide has more slides, including the first seven
Yeah,
and the
yeah, you
first
can just
50.
you can omit the first one, no problem. You need not keep it. The only reason why I put it was okay, that much was taught on that day and the recording did not happen.
And the
Initially, there
other
was
slides.
the second chapter. One sec, I have posted everything. I have posted everything. What I have done even till yesterday, I have posted. You want the slides or are you talking about the recording?
The slides, ma'am.
Slides. Today, I'll be posting the slide of this chapter because today we are completing it.
Okay.
See, what is actually happening is I thought I should explain that to you. What is actually happening is I write something on the screen. Okay. Now, unless I save it as if I just straight away just give it to you as a PPT, yes, you are able to see what I've written there. Yes.
Yes, ma'am.
Right. So, what is happening is every time if I have to just share with you the class that I have done, whatever just happened will be the result. You will wonder why I have shared a PPT 2 times. That is the reason why I'm trying to share it only at the end of the chapter. Is that fine?
Even if you share it multiple times, there's no problem.
There is no problem, but then it can happen that people who don't come to the class will simply miss out. They won't understand what has happened. That is the reason why I see you have attended class, you yourself asking me this question, Madam, why did you share it twice? It is not twice. If you have opened it, you will know that one of them is just of the first class and the others are for the entire chapter. Okay, if you want, I can share it then and there each day, whatever I'm doing, I can share it. But then we are supposed to share the recording with you people. That is the instruction given to us. Okay, so that's the reason why the recording is being shared every day. If you want, I can share the PPTs also every day, not a problem.
Okay.
Okay, yeah, fine then. So let's
And
just
the
start.
syllabus will be until uh,
Syllabus will be the first 2 chapters, that is chapter number 1 and chapter number 3 completed.
okay,
Today
okay,
I'll be finishing the syllabus for the test.
okay.
Okay, and what can be asked? See, first thing is how many are there in the class today? Only 2, only one? Only one student? This is very pathetic. Where is this Abhinav and all? It's really pathetic that others have not come to class. See, the thing is, there is no MCQ. No MCQ or filling the blanks will be asked in the test. It is just going to be short questions. Short questions. What all can be asked? What did we start off with? We started with lattice. Then we talked about the primary cells. We talked about brevis lattice. Then we talked about reciprocal lattice. Then what else was there? Can you recall what all we studied? Then indexing of the planes was there. Then the relationship between reciprocal lattice A star, B star, C star, and ABC. That's about it. Really nothing much. And then structure factor, which I have done in the last class. That's it. Not really much. And I don't see why you people should not get marks. But then only thing is, when you go through this, you should also remember what are the things that you must recall in an examination. Like for example, to talk about these, if you have to do the structure factor, you know that you need to know R1, R2, R3, whatever for the given cell, for a given structure, for FCC, BCC, where are the atoms located? You should be able to write. Similarly, you should be able to write the G factor also. Okay, if you don't know those, you will not be able to do the rest of the derivation. Okay, so it's going to be completely closed book. It will be a examination which will be monitored on the screen. So please remember whatever you have to. Any doubts? Okay, so let's just go ahead. So in the last class, we were talking about the structure factor for BCC, FCC, simple cubic. So what is the structure factor? Structure factor is essentially going to tell you about the reflections from the various. I'm taking a cell. I have atoms sitting in various positions. And these, of course, are also planes. If I take many such cells, I will be talking of planes. And then we are talking of what are the atoms sitting in these positions, the locations of these positions. And we are talking about the G for these planes. And ultimately, we are able to arrive at an equation which is going to tell you what are the possible reflections. What are the possible reflections? Like, for example, when I'm talking of structure factor of a monoatomic BCC, first thing is I should know what is the structure. What is BCC? That's the first thing I should know. I'm just repeating what I have done in the last class. So what is it you first have to know? You have to first remember that it is a primitive simple cubic lattice. You can consider it as a primitive simple cubic lattice. Next question is, what is the basis? Next is, what are the positions of the basis? Where are the atoms located? Like, for example, here, the basis consists of two atoms. And where are they located? At one corner and at the body center. That means it is located at 0, 0, 0, half, half, half. So write them as vectors. So when you write them as vectors, you will write R1 is 0, R2 is A by 2, X cap plus Y cap plus Z cap. Then immediately you have to put it into the structure factor equation. When you put it into the structure factor equation, the structure factor equation is going to be summation Fg into exponential Ig dot R, Ri, let us say, where you're going to do a summation over I. So you have to, next thing that you need to know is writing your G. You should know how to write your G in terms of X cap, Y cap and Z cap. Okay, and you should know it for a simple cubic lattice because our lattice we assumed is simple cubic lattice where the bases were two atoms occupying two positions so that ultimately you are going to get a BCC. Okay, so what all should you remember? You need to remember this. You don't have to remember. This is just logic. Okay, but this you have to remember. Okay, then you put it into the equation because there are two atom positions. So you will get two expressions. The first expression will be exponential of 0, which is 1. And the next is going to be exponential of I by m1 plus m2 plus m3. And what is this m1 plus m2 plus m3? m1, m2, m3 are simply your H, K, and L. Okay, so put them there and then look at under what conditions you will get 0 as the structure factor. You can see that you will get 0 as a structure factor whenever the second term is going to be equal to -1. When will the second term be equal to -1? Second term will be equal to -1 if m1 plus m2 plus m3 is an odd number. So when it is an odd number, then the structure factor is 0. That means there is no reflection that you will see in your X-ray pattern. So this means that for a BCC, M1 plus M2 plus M3 or H plus K plus L should be even. If it is odd, you will not see reflection. That's it. Okay. So it has to be even. So if it is odd, you've seen that it is not going to give you reflection. So what is the meaning of saying it is odd? What is the meaning of saying it is odd? M1 plus M2 plus M3 can be 1. If M1 plus M2 plus M3 is 1, then what are the reflections possible? The reflection possible will be 1, 0, 0. I mean, so the plane that we are talking of is HKL, we are talking of is 1, 0, 0. So no X-ray will diffract from 100 plane of BCC and give you a peak. It will be a destructive interference. Next thing, when M1 plus M2 plus M3 is 3, 3 is odd. M1 plus M2 plus M3, 3 means what? 1, 1, 1. So that means reflection from a plane 1, 1, 1 is not possible. You will get a zero intensity peak. Similarly, M1 plus M2 plus M3 equal to 5. So M1 plus M2 plus M3 equal to 5 means what possibilities can be there? 1, 2, M1 plus M2 plus M3, 3. Sorry, let's go back to M1 plus M2 plus M3 is 3. 3 means what possibilities are there? 1, 1, 1. Also 1, 2, 0 is also a possibility. 1, 2, 0 is also a possibility. So basically from this M1, M2, M3, the sum, this odd even, you should be able to write the HKL of the planes which are not going to give you reflection. Similarly, write for planes which are going to give you reflections. Okay, now you can do the same exercise for FCC. For FCC again, what is it you have to know? That it is a primitive simple cubic lattice, but then how many atoms are there? The basis will consist of 4 atoms. Where are the 4 atoms located on the cube? You can see that the 4 atoms will be located one at the corner, then the 3 nearest body face centered, the 3 nearest face centered. So these 4 will form the basis. So how do you give their location? If you take these axes as x, y, z, then you can take their locations as 0, 0, 0. This one you can take it as, let us say, half, half, 0. Then here you can take this as 0, half, 0. You can take the one on this face, you can take it as 0, half, half. Are you understanding how we are writing this? Pujita?
Yes, ma'am.
Right. So you are able to get your R1, R2, R3 and R4. Then you need G. To get the structure factor, you need G. So G for a simple cubic, you certainly must know. Or you must at least know how to arrive at that. Okay. So once you have got this, because I again told you, where is this coming from? I will explain. G is coming from, like for example, if I'm talking of plane HKL, HKL again I'm telling you is M1, M2, M3. Then we have seen for a cubic system, it will be 2 pi by A into H A star plus 2 pi by A, it is cubic, so 2 pi by A, K, B star, or let me not even write all this. I'll just take you to that page where we wrote our G. Yeah. Like for example, G, we actually started this by writing G100. Then we wrote G100 is A star. Similarly, we got G010, we called it as B star. Then G001, we called it as C star. These are the primary reciprocal lattices in the 3 directions. Then this would imply that if I am talking of another plane G200, okay, because the distance between the planes is now half of G100, 100, this will become 2 times A star. Or in general, I will say GH00 is H times A star. Okay, so if you extend this logic to all these 3, you can also write for a general GHKL. GHKL will be H times A star plus K times B star plus L times C star. And what is this HKL? HKL is the index of the plane for whom, for which, for that family, we are talking about the reciprocal translation vector G. So G is the reciprocal translation vector. So G is like, I'll give you an analogy. G is like 5 I cap plus 2 j cap plus 3 k cap. That's general. 5, 2, 3 I wrote. So that's like HKL. Only thing is here I am talking in terms of Hij, I'm talking about a real vector space. But then when you're talking in terms of reciprocal space, you would write it in terms of A star, B star, C star. A star, B star, and C star are like your Ijk vectors, unit vectors, or they are like your X cap, Y cap, Z cap. Only thing is this is a reciprocal space. And this HKL have a meaning. HKL is talking about the real space, and there you are talking about a family of planes, equidistant planes HKL. All this family can be represented by one single point and one single vector called GHKL. Okay, so you should know how to write this. Next thing, this GHKL, for example, in the case of cubic, what happens? A equal to B equal to C. Directions are different, but A equal to B equal to C. And you have seen that it is equal to A equal to B equal to C was equal to 2 pi by A. So here I am writing vector A, whereas here this A is actually the size of the cell. Okay, and then you can write it in terms of vectors and see how you have to write your A star. I'm sorry, this was A star, B star, C star. So how you should write it as a vector that you can see. You will see that you can write it as 2 pi by A x cap, 2 pi by A y cap, 2 pi by Z by C Z cap. But then A equal to B equal to C, therefore it is just A. Okay, so we just discussed structure factor. So you should know how to write the structure factor for at least three of the lattices: simple cubic, BCC, FCC. Okay, and in FCC, what did we get? In FCC, we got structure factor non-zero when M1, M2, M3 are all even or all odd. So that is a condition, all even or all odd. So you will see reflections from 111, 200, 220, etc. Okay, and if that condition is not met, you will get structure factor 0, or you will not be able to see those reflections. These conditions you should know. Why you should know that condition also I will now explain. Now, next, simple cubic. Simple cubic, we have seen that it is a simple cubic primitive cell with just one atom at a corner. That corner is 0, 0, 0. It is sitting at a corner. Therefore, structure factor is 1 into F. 1 into F, which is F. 1 is this. Okay, so that means all combinations of M1, M2, M3 are possible. There is no restriction. Therefore, I will tell you a secret that you will see when you're talking of a simple cubic lattice. In a simple cubic lattice, you will see more reflections than in the case of BCC or FCC. And you will find that they are equispaced also. When I'm talking of more reflections means I'm talking of XRD pattern. What is an XRD pattern? XRD pattern is this figure that I showed you. Okay, here you see the peaks are not. So this 100 means from all 100 planes, this reflection has happened. You are able to see that peak. Similarly, 200, 211. But see their spacing, they are not very close to each other. But in the case of a simple cubic, you find that they are close and more number of peaks will be possible. Because every reflection is valid. It will be constructive. Leave out diamond lattice. It is not required. You don't have to, at your stage, it's not required. I just wrote it for the sake of completion. Don't bother. Then, today let us see how exactly indexing is done. Okay, so to do the indexing means writing HKL above each peak. Okay, that is called indexing. So to do the indexing of peaks, you need to know. You can't just start from 0 and do it. You need to know some partial information you should know. You may have to know the symmetry of the lattice. When I'm saying symmetry means whether it is simple cubic, you need not know whether it is BCC, FCC and all that. You should know that A equal to B equal to C. If I know that, then I can start doing this. Next, I'm going to give you one relationship here. For a general orthogonal crystallographic system, what is the meaning of orthogonal? What is the meaning of orthogonal in mathematics?
Like perpendicular.
Perpendicular. So, if I'm talking of a crystal system which is orthogonal, okay, that means alpha equal to beta equal to gamma equal to 90 degrees. The angles are all 90. But I am not saying that A equal to B equal to C. That need not be the case. A need not be equal to B need not be equal to C. Okay. So if I take a system that is just orthogonal, but A need not be equal to B, need not be equal to C, then you can talk about the distance between the planes. Any plane HKL, you can talk about the distance between adjacent planes of the family HKL. It will be given by under root of h square by a square plus k square by b square plus l square by c square. Okay, here we are saying that A need not be equal to B, need not be equal to C, but your alpha equal to beta equal to gamma equal to 90 degrees. Okay, now how are we going to use it? Let us see. To do X-ray pattern recognition, you first of all have to use Bragg's law. What is Bragg's law? 2d sine theta equal to some m lambda, where m can take values 1, 2, etc. Okay, but all the time you don't bother about 2 and all, you will see only the first order 1. Okay, and you must be seeing that normally I would have written 2d sine theta equal to m lambda, but here I am putting one HKL here, one HKL here. That is because D depends on what is the HKL of the family. D depends on what is the HKL. That's the reason why I'm writing HKL there. And again, the corresponding theta that can give you reflection also depends on, because it is from those HKL. So I'm writing HKL. So theta is not a constant. It depends on the family from which the reflection is happening. Family of planes from which the reflection is happening. Okay, so now what we can do here is just simplify this. Simplify this Bragg's law and write. You can write an expression for sine theta. Take everything else to the right hand side of the equation. You get sine theta equal to m lambda by 2d. M lambda by 2d. I'm not talking HKL now. So sine theta equal to m lambda by 2d. Now let us go to a cubic crystal. Orthogonal system, but cubic. Cubic means A equal to B equal to C. Okay. Now, what will happen to your DHKL? DHKL will become, just go to this equation and see, DHKL will become under root of h square plus k square plus l square divided by A. Divided by A, because A is equal to B equal to C. So you can take a common denominator and then take it out of the under root. So you'll get under root of h square plus k square plus l square by A. Okay, so we have to now use this in this equation. So you can, what you can do is sine theta will be lambda into under root of h square plus k square plus l square divided by 2a. Now let us square it. If you square this, you will get sine square theta equal to lambda square into h square plus k square plus l square divided by 4a square. Now for a given crystal, lambda by 4a is a constant, because you are using one X-ray of constant lambda. Then you are talking about one material which is having some constant structure. It is cubic, A is a constant. Therefore, lambda by 4 pi will be a constant. Yes or no? For the experiment you have performed, lambda by 4 pi will be a 4a will be a constant.
Yes.
Right. So what are the variables? HKLs are going to be different. Theta correspondingly will be different. Okay. Or now what we'll do is, we can simply say that sine square theta will be proportional to, directly proportional to h square plus k square plus l square. Or you can simply say that sine square theta by h square plus k square by l square is a constant. It's a constant because it's after all going to be equal to lambda square by 4a square. It's a constant for the given structure. Now what we will do is, instead of writing HKL, we are going to simply write H as M1, K as M2, and L as M3. I'm just doing it because normally books like to use this language, so I'm just writing. Okay. So we will write that sine square theta by m1 square plus m2 square plus m3 square is some constant for a given material. Okay. Now, what are m1, m2, m3? m1, m2 and m3 are integers. Integers which can take values 0, 1, 2, etc. Now, what all combinations can be there? I have explained a few minutes back. The smallest will be 1, 0, 0. The second can be 1, 1, 0. The third can be 2, 0, 0. 1, 1, 1. Like that, you should know how to write these combinations. Now, we are talking of the sum of the squares. When you do this, you are going to see that some combination, some numbers will not come. M1 square plus M2 square plus M3 square can never be 7, can never be 15, can never be 23, can never be 28. Why? It can never be like that because you can't have integers M1, M2, M3 which can come together and give you 7, 15, 23, 28. It can never happen. Okay? So this knowledge also you keep in mind. Next, how do you actually find the structure? You are given an X-ray pattern. How do you find the structure? Assuming it is cubic, but you don't know whether it is simple cubic, BCC or FCC. So what you have to do is, you have to take your X-ray pattern. The pattern is given to you. It will look like this. Okay? Okay. Now what you do is, this will be 2 theta. This is the intensity. Okay? So corresponding to this angle, there is a reflection. So find out what is this 2 theta. Similarly, note down what is this 2 theta. Note down this 2 theta, this 2 theta. So you are able to get all the 2 thetas corresponding to different HKL. You got your 2 thetas. Okay. Now what you do is, take the smallest 2 theta, get the smallest, or first of all, you have to make a table. You have to convert theta into radians, keep theta in radians, okay, and then get your sine theta. From 2 theta, get your sine theta, okay, then get your sine square theta for all the peaks. Okay, then look at the ratio of sine square theta. Look at the ratio of the smallest sine square theta, the next third, fourth, fifth. So what you will do is, if I call this as 1, if I call this as sine 1, sine 2, sine 3, sine 4, sine 5, etc. Do sine 2 by sine 1. See the ratio. Sine 3 by sine 1. Get the ratio. Sine 4 by sine 1. Get the ratio. Sine 5 by sine 1. Get the ratio. And if these ratios are all going to be like this, 1, 2, 3, 4, 5. Like, one second. If the ratios are not this, if the ratios that you're going to get are all going to be like this, 1, 2, 3, 4, 5, 6, 7, continuous. Close your eye and say that this is simple cubic. Close your eye and say it is simple cubic. Okay? You know that all reflections are possible and you are getting these ratios. So it is simple cubic. Then you can say that this first has to be 1, 0, 0. M square, M1 square plus M2 square plus M3 square is 1. Next, what will be the next one? Next one will be 1, 1, 0. M1 square plus M2 square plus M3 square will be 2. See the ratio, 1:2. Then the next one will be 1. So the next one will be 2. Sorry. The next one will be 1, 1, 1. Next reflection will be 1, 1, 1. What will be the M1 square plus M2 square plus M3 square? It will be 3. Next will be 2, 0, 0. What will be M1 square plus M2 square plus M3 square? It will be 4. So you will see peaks corresponding to all the planes. simple cubic. And if you see the ratios, it will be always 1, 1, 1. Sine square theta ratios will be 1. Next, let us go to, are you understanding this, guys? Pujita?
Yes, ma'am. There's like some noise behind, so I'll use the chat box.
Okay. Next, let us go to BCC. In BCC, you already know, we did the structure factor and found that BCC will allow only M1 plus M2 plus M3 odd. I'm sorry, odd is not allowed. Only even is allowed. Only even is allowed. Only even is allowed means what are all possible? This is possible. This is possible. This. These are the possibilities. Write m1 square plus m2 square plus m3 square and see. You won't see 1, 3, 5, 7 is anyway not going to be there. 9 is not there. So you're seeing fewer number of peak systems are possible. Once again, do your sine square theta. You need not do this constant. Sine square theta ratio, if you keep doing, you'll be able to see that the first peak and the second peak ratio, then the third peak, first peak ratio, fourth peak, first peak ratio, fifth peak, first peak ratio. You will get this 1, 2, 3 ratios of sine square theta. Then you know that this is a BCC crystal. And you will find that they are not going to be equispaced. Similarly, FCC, if you do, FCC, we have seen that M1, M2, M3, they should all be odd or all should be even. So you are going to see 111, 200, 220, 131, 222, 133. And if you see the ratios here, you'll find that the ratios are going to be 3, 4, 8, 11, 12, or let's not talk about this. I will show you a real demo. There is a link given here. You people can just go see that link. It will show you one video. Okay. For a cubic system, how do you do the indexing? Then you will ask, Madam, we did indexing. From that, how are we going to get ABC? Remember, 2D sine theta is M lambda. M is 1. You know lambda because you used your X-ray. If I know HKL, I can get my D. Okay. I can get my A. It is just back calculation. Put everything that you know, only A will be the unknown. You can get your A. Okay, so let's just see this. Instead of playing it, what I'll do is I'll just show the relevant calculations. Like for example, here you see, you get all the peaks. This is a cubic system. First, you get the position of all the 2 theta. 2 theta. Then get theta in radian. See here, the author has used Excel sheet. So he has got theta in radians for the first 7 peaks. Next, what will he do? He will get sine theta. With theta in radians, he will get the sine theta. Are you able to see the screen?
Yes.
Right. So he gets the sine theta. Sine theta he is getting. Next, he will get sine square theta. Theta in radians, sine square theta. Next, what he does is he starts getting the ratio of sine theta. How do you get the ratio? Not sine theta, ratio of sine square thetas. So the first one is 1 divided by 1, so it will be 1. Yeah, so it is 1 divided by, so it will be 1. Now let us look at the next ones. Look at this. You can see that sine square theta of the second one, 0.2171 is almost double as 0.10885. So if you divide the second by the first, you get 2. Similarly, third by first, you get 3. Fourth by first, you get 4. Fifth by first, you get 5. Okay, you may not get exactly 5. You may get 5.01, 5.02. That's okay. But if you get 5.5, then you are wrong. Something is wrong. Okay. So first 7 peaks, this guy gets the ratio for sine square theta. Now you see these 1, 2, 3, 4, 5, 6, 7 is impossible. You know, 7 is not a permissible combination of m1 square plus m2 square plus m3 square. 7 is not a permitted combination. Okay, so this is not m1 square plus m2 square plus m3 square. This is not m1 square plus m2 square plus m3 square. So what he will do is, he multiplies it by 2. He multiplies it by 2, the entire thing by 2. Okay, and see what he gets. 2, 4, 6, 8, 10, 12, 14. The very fact that 7 appeared itself tells you that this is not a simple cubic system. You can't take this column as it is. You are multiplying it by 2. And now you see what you're getting. 2, 4, 6, 8, 10, 12, 14. All are permissible m1 square plus m2 square plus m3 square. Okay. Now, this 2, if you are able to write your HKL, so finally, forget this part. Just see the HKL. 2 will give you a HKL of 110. So 100 was not possible. This is not definitely simple cubic. 4, what will it give? 4 is giving you 200. 6 gives you 211. So from this, what are you able to conclude? What are you able to conclude? What kind of a structure do you think it is? You're finding m1 plus m2 plus m3 is even, or h plus k plus l is even. Are you not seeing that in the last column? 110 means what? 1 plus 0 is even. 2 plus 0 is even. 2 plus 1 is even. So you're seeing that, the sums of m1 plus m2 plus m3 is even, or h plus k plus l is even. So which is this structure which is going to give you, which follows this? Anyone? Anyone? Not able to say?
Is it BCC?
Exactly. It is BCC. It is BCC. See here, BCC 110, 200, same things you got. So basically, I just try to show you how one can use an Excel sheet, okay, and then use your data, the X-ray diffraction pattern, pick up all the true thetas, convert them into thetas, convert them into radians, get your sine theta, sine square theta, and you can actually get the HKL corresponding to each of these peaks. Once I know HKL, I can get my D. I can get my A. It's only back calculation. I can always do it. Because after all, 2D sine theta was lambda, m is 1. Okay, so D is h square plus k square plus l square divided by A. I know HKL, I can get my A. I've got my, the structure of my cell, it is BCC. I get my A also. So this is how one manually, in fact, when I was a student, what happened was we used to do this way, but of course softwares had come by then. Softwares were there. Now no student really at the PhD level will be using or doing an indexing by the method that I told you. But then you should know this method. Unless you understand this logic, you won't really be able to get anything from using a software. Now lots of softwares are available. So the data you just feed, you will be able to get your parameters. But then how it happens, that you will understand only by looking at this. Okay. So any student should get a feel for this by actually at the MSc level and BSc level, we normally expect students to manually do this and understand, so that if there was a lab, this is what you would have done done in the lab. We would have given you an X-ray pattern and made you do this exercise. Okay, so with this chapter is done. So in the next chapter, this YouTube is there. This YouTube is a long video. You can also see for non-cubic how they do it. Of course, I won't be asking so much in an examination, don't bother. In a final examination, end semester examination, I'm definitely going to give you some data and make you do an analysis because it's a 3-hour examination. Can we not do that? In a 3-hour examination, one can do that. I will ask you in the 3-hour examination. But in Friday's test, please don't absent yourself. No makeup is given. We have all decided. Because there is no reason why people should not take the exam. If you get 0 in the first test, you're going to get 0 in the makeup also. So it doesn't really matter. Please take it, finish it. Okay. And then I told you, yeah.
My vaccination slot will be in this week, so if it's afternoon, I'll definitely attend. But yeah, I just thought I'll inform that
No,
before
no,
that.
what is it? I didn't get you.
My vaccination slot, it was announced that it will be in this week. They still
Okay.
didn't tell which day it will be, the
Okay.
second dose.
Ah.
So if it's in afternoon, I'll try to attend. But
Can you postpone your examination to your vaccination to the next week? Because I know in India it is possible. Because you may
okay,
spoil many examinations if you get a fever.
okay, I'll talk to my dad.
Hey,
It's
shall
through
I tell you why?
TCS, so like
Oh,
he needs
TCS,
to do.
it can be done. TCS, it can be done. I know it can be done. You can
Okay.
always. Did you take one vaccine so far?
Yeah, ma'am.
One vaccine. And how many days is it?
Um, like the after effects or the slot?
No, no. When did you get the first lot? When did you get the first jab?
I think it was 2 months ago. Yeah.
2 months ago. 2 months ago. 83 days or something, no? What is the number of days they are asking now? Oof, how many days? I forgot what it is now. No, I am only telling you, try to keep it for the end of the week. Okay, because
Okay.
if you get a fever, you'll spoil all your exams.
Okay.
Just look at it if it's possible to get it on a Saturday.
Okay.
Okay, because many people, even the first jab, if they don't get fever, second one they are getting fever, body pain, all these things are there. Just look at it once. And another thing is, this examination will be from 4:30 to 5:30 on Friday.
Okay, ma'am.
Okay, it's 4:30 to 5:30. That's the time given. I think all our exams are going to be 4:30 to 5:30 only.
Yeah, most of them.
Yeah. So what we'll do is, the question paper will be put on LMS. You will just open it, take a picture of it immediately on your cell phone. After that, LMS is not then required. You come to Google, switch on your camera, write your examination on white paper. At the end of it, scan it, upload on LMS.
Same Google Meet as the class.
Yes, same Google Meet as class.
Okay.
Okay, yeah. Okay, then. Good day. Stop the recording.